There are times in calculus when you're given an equation that's written implicitly and you need to take the derivative of it. Of course, if we could rewrite it explicitly, that would be the best because it's easier to take the derivative of an equation written explicitly. But there are times where you cannot rewrite it explicitly, and so we have to perform implicit differentiation. Now at this point, some people might be wondering, well, what's the difference between an equation in explicit form and an equation in implicit form? So let's go over those. The explicit form of an equation is when one of two variables is explicitly written as a function of another. So let's look at some examples of equation in explicit form. Y equals 3x plus 5. So it's a line, and the y is explicitly written as a function of x. Another one could be y equals 3x minus x squared. Again, the y is explicitly written in terms of x. How about s of t equals a negative 16t squared plus 20t plus 200. Okay. S is written explicitly as a function of t. And I keep on using the word function, and that's because all of these are functions, and that is the way pretty much to tell that it is in explicit form. Now let's look at the definition of implicit form. The implicit form of an equation is when it is not an explicit form. Alright, so let's look at an example. Let's say we have x squared plus 2xy plus y squared equals 5. Okay, so this is in implicit form. And the thing that happens here is because of the y and then this y squared, or this x and this x squared, there's no way to take this and rewrite it as y equals some other equation, like we were able to up here. So it's an implicit form, and in this case we're going to have to use implicit differentiation. Now, as we're going to see, we want to take derivatives and work with things that are functions. I've actually probably said that a number of times through Algebra 2 and Pre-Calc, that we like functions because they're so much easier to work with. Now, we're still going to be able to work with an equation in implicit form, and it's not super challenging, but there are a lot of added steps in analyzing or taking the derivative of an equation in implicit form. Okay, so let's go through the steps for implicit differentiation. Okay, step one. Step one is we're going to differentiate both sides with respect to x. Excuse me. Step two. We're going to place all dy dx terms on one side and all the other terms on the other side. So we're going to place all dy dx terms on one side and the other terms on the other side. Okay. Step three. We're going to factor out dy dx. And then step four, we're going to solve for dy dx. Okay, so there are the 4 easy steps to finding the derivative using implicit differentiation.